I'm Dr. JoAnn Ballor from IMDEA Materials Institute, and this is the second episode of UTIFE Science Explained. In our first video, we explored why additive manufacturing requires a new approach to designing materials. In this episode, we'll focus on a specific class of materials, Eutectic titanium iron alloys. What makes these alloys unique, and why are they particularly suited to additive manufacturing? Sound interesting? Stay tuned! Eutectic titanium iron alloys are a great example of an alloy that does not perform well when traditionally manufactured, but does perform well when additively manufactured. When we talk about eutectic alloys, we're talking about a specific type of alloy that, when cooled from the liquid state to the solid state, forms two separate phases at the same time. This creates a layered structure that can provide high strength. The size of these layered structures depends on the speed of cooling, with faster cooling forming smaller structures and slower cooling forming larger structures. In eutectic titanium iron alloys, traditional manufacturing methods create two large structures that are brittle and do not provide good performance. However, when additively manufactured, titanium iron alloys can create ultrafine eutectic structures that have both high strength and good ductility. In addition, the layer-by-layer approach of additive manufacturing allows these ultrafine structures to form uniformly throughout the piece, rather than just at the surface or in very thin sections. Initial testing of additively manufactured titanium iron alloys shows that they can exhibit both high strength and good ductility in an intermediate temperature range, from room temperature up to approximately 450 degrees Celsius. This performance, as well as the relatively low density of titanium iron alloys, means that they could be suitable for environments with demanding needs, such as for aerospace applications. So, what's the catch? While these results are promising, like many high-performance alloys, titanium iron alloys are susceptible to cracking during printing, which is preventing their adoption into industry. In our next video, we'll look at two key challenges in additive manufacturing: how processing choices can affect microstructure, and how processing choices can affect critical defects such as cracking. I'm Dr. JoAnn Ballor from IMDEA Materials Institute, and this has been UTIFE Science Explained. Stay tuned for the next episode.